like you will get, it's not like forgetting lecture one. Like once you solve problems and go through the contents after lecture one onwards, like you will see what exactly, like you will try understand it properly.
Okay, ma'am. I'll go to lecture 2 then. Thank you.
Yeah, yeah. So how was the quizzes? How was
It
it?
was okay, ma'am. It was okay.
What about others? Manashita, how was your exam?
Yes, ma'am, it was good.
Okay. What about Prash?
Good, ma'am.
Yeah, okay. So yeah, so today is the open session for week 11. So if you have any problem in the case in some assignments or lectures from week 11, you can ask me. So after this week, there is going to be all the revision sessions. So specific lectures we can discuss there. So if you have any doubts from week 11, please ask.
Ma'am, I have a question from AQ 10.1. Is it okay?
10.1.
Yeah.
Okay.
Ma'am, the first question says a manufacturer of a certain brand of rice cereal claims that the average saturated fat content does not exceed 2.4 grams per serving, which means the null hypothesis must be less than, the null hypothesis is mean is less than or
Wait,
equal
just
to 2.4.
let me check the question once. Which
Yes,
question
ma'am.
number? Which question number?
First one, ma'am. Question number 1, first
Okay.
AQ of week 10.
Okay, wait. Yeah, what is the doubt in this question?
According to the question, the null hypothesis must be mean less than or equal to 24, right?
Okay, that says a manufacturer of a certain brand of rice cereal claims that the average saturated fat content does not exceed 2.4 gram per serving. Okay.
What I think is,
You're saying is null hypothesis should be less than 2.4.
yes, ma'am, mean should be less than 2.4 must be the null hypothesis.
Why is that?
Because that's what it is claimed, ma'am. That is what is assumed now. It's not saying, the question is not saying the average is exactly 2.4 or average is nothing but 2.4. It's saying average does not exceed 2.
See, here you have to check whether it exceeds 2.4 gram or not. So you were assuming that it was 2.4, and then you have to check whether it exceeds 2.4 or not.
What I said makes sense.
You said that we want to check for
Null hypothesis. Yeah, ma'am. Null hypothesis must be mean less than or equal to 2.4, which is not given in any of the options given.
okay. So for I'm sorry. So for this, like whenever you take the null hypothesis, just like take the equality sign. We maintain that in the null hypothesis, and whenever the alternate, whatever you want to check, there the inequality or the not equal things come in alternative hypothesis.
No, I don't get what you're saying, ma'am.
Excuse me, ma'am.
Yeah, just hold on. Who is that? Okay, so the problem is in null hypothesis, right? Alternative, there is no issue.
Yeah, it's just null hypothesis.
It is null hypothesis, yeah. Okay, we'll check. We'll come up with a correct explanation for this. If it is wrong, we will change it on the portal. Yeah, because there it says the content does not exceed 2.4 grams per serving. And this is what we want to check. And that's why the alternative is mu greater than 2.4. Okay, we'll check this question once. Like,
Ma'am, I have a doubt in lecture 10.1. May I ask?
all of you haven't started week 11 yet. Like last week was 10th.
No, ma'am. We are still in week 10.
Okay. Nobody has doubt from week 11. Last week there was a session for week 10 and nobody shows up.
No, a lot of people are, lagging behind in the syllabus. That is why.
Okay, you can ask your doubts from week 10 then. Looks like nobody has studied week 11. Okay, so you also had doubt in the lectures, right?
Yes, ma'am.
Yes, ma'am.
Okay, so you can just ask what's that?
Ma'am, in lecture 10.1 at minute 7, 35 seconds, sir is explaining about tossing a coin 3 times.
Okay.
Yeah, and I'm not able to understand what's x1 to xn there. And firstly, my doubt is whether we are just tossing a coin thrice, or are we going to repeat this experiment for n times?
What?
Like if I have a coin and I'm just
what time you said? 7.
7 minutes 35 seconds.
Okay, your doubt is?
My doubt is whether I have a coin, and should I just toss it 3 times, or should I repeat this experiment of tossing a coin 3 times over n number of times, let's say over 50 times or 1000 times, something like that.
says 3 times, no?
Okay, so that means only 3 tosses in total, right?
You're tossing the coin
Okay.
3 times. Yeah,
Okay.
you're tossing the coin 3
And
times.
what's x1 to xn?
Yeah,
What is x1 to xn?
x1 to xn.
If I'm tossing a coin 3 times, then I should only get x1,
Go
x2, and
back
x3,
to the
right?
lecture. Let me go back to the lecture. Wait.
Some outcomes to accept the null, which generally we
Okay.
normally expect to be true, and then hit.
There, when he's explaining the acceptance set and the test, there you're talking about?
Yes, ma'am.
Okay.
Basically, I'm not able to understand how we are proceeding with the experiment, what is the outcomes and everything related to that.
So, the acceptance set and test is independent of what example he had taken before.
Yeah, but I want to understand it from the beginning. Like what is x1 to xn, what is x, then what is a scripted x, everything about it. All the variables
Also,
that are being used.
also what is acceptance set and what is a test?
Okay. Okay. So, acceptance set is what, like whenever there is something that you want to check, that you call it as null hypothesis, and if you want to check whether that hypothesis is true or not, and you have some alternative hypothesis for that, if your null hypothesis doesn't like satisfy, then you will accept the alternative hypothesis. And what is acceptance set is like a set of all the outcomes for which you are accepting the null hypothesis. Let's see the example that he has done after that. So to check whether the coin is authentic or not, so we have to check that. We have to check, what we have to check is whether the coin is like unbiased or biased, basically. So in order to check that, we'll have to take the null hypothesis to be, we want to test whether probability of H or probability of tell equals 0.5 or not. So that is our null hypothesis, that let's say we are taking probability of H to be 0.5 and probability of and the alternative hypothesis is we are taking to be probability of it equals some other number apart from 0.5. Let's say it is 0.6.
Can you please be a little louder? You're not properly audible.
Okay. Yeah. So we wanted to check whether the coin is authentic or not. So basically we have to check whether probability of occurrence of head or probability of occurrence of tail is 0.5. So that we can take is it as the null hypothesis, that is probability of H equal 0.5, and alternative hypothesis can be something else apart from 0.5. So in this case, let's say we are taking probability of head to be 0.6. Now we have to check okay, so we have to, let's go to the same example. Wait, somewhere you had solved. Okay, so the example was tossing a coin 3 times. So if you toss the coin 3 times, we know there are going to be 8 outcomes. So the first case, if your acceptance set is 5, so what is your acceptance set? Acceptance set is going to be like set of all those outcomes for which you will accept your hypothesis, that we call as acceptance set.
Sorry to interrupt, ma'am. Can we
Yeah.
go over this experiment from the very beginning, from x1 to xn, from that part?
From the beginning.
Yeah. Well, sir has
Okay.
written x1 to xn is IIDx from that very line.
Okay, I will go back from the first slide itself.
Yeah.
So okay, yeah, example is the same whether the coin is authentic or not. So suppose you have a coin that would be authentic or counterfeit, you may toss the coin multiple times and observe the results. How will you test whether the coin is authentic or counterfeit? Okay, so null hypothesis, alternative hypothesis, you can decide, right? After that, so you have like 8 outcomes when you toss the coin 3 times, HHH, HHT, and so on. So there will be some set of outcomes for which you will accept your null hypothesis. You will accept that the probability of occurrence of head is 0.5. Let's say you toss the coin. Let's say you have tossed the coin 3 times, and the result that came out is head or head tail. So it may, like, if you are getting more number of heads, you may like feel like these outcomes can be in the acceptance set, right? So the set of all the outcomes for which you will accept your null hypothesis, those sets will consider as the acceptance set.
Ma'am, 1 minute, ma'am.
So yeah.
What are the kind of, I mean, can you repeat the acceptance definition of acceptance set once again?
The kind, like acceptance set is basically the set of all the outcomes for which you will accept your null hypothesis. So in this case,
Ma'am,
your null
yeah.
hypothesis, probability of occurrence of head is 0.5. So
What are
if
the
you
outcomes? What are the outcomes for which we accept the
outcomes
null hypothesis?
from here, we cannot say that what all outcomes will be there.
Okay, okay, okay,
We'll
okay.
just proceed. Yeah.
Okay, ma'am.
So let's say you have 10 or some samples. You have the experiment and you have some samples from that experiment, and those samples, like if those samples will belong to the acceptance set, we'll say we'll accept H0. And if those samples won't belong to the acceptance set, we will say we will reject our H0.
How can we have 10 samples when we're causing the coin only thrice?
So okay, I'm not saying 10, I'm saying some samples here. So like if you're tossing the coin 3 times, you have what all outcomes? You have HHT, HH,
We have 8 outcomes
HHH.
in
You
total,
have
ma'am.
eight
So
outcomes,
ma'am,
right?
x1 equals
So
to
so
HHH.
x1, x1 is HHH, x2 is, let's say, TTT, then x3 is HTH, and so on. These are your like samples that you're taking.
Yeah,
So we
so
have
we are repeating the experiment of
Or
tossing a coin thrice over multiple times, right?
over multiple
Let's say
uh,
50 times. So we'll have x1, x2, x3 up till x50, so on.
yeah. No, can you repeat? Can you repeat what you just said? Hello?
Yes, ma'am. I'm saying that we are tossing a coin 3 times over n number of times. For example, I'm tossing a coin 3 times for the first time. Then I'll record the outcomes as HHH. Then I toss it again. Then I record it as TTT, for example. Similarly, third time I recorded as HTT. So on X50. That means throwing a coin.
You're not audible.
Are we only discussing week 11 today?
Yeah, we are supposed to discuss week 11 today, but nobody was asking from week 11.
Yeah. And I want to ask one, like, will we have week 12 or?
No, there will not be a week 12 content. Like we'll post it on, we'll send an announcement. There's no week 12 content. We will keep on, like, we'll put some sessions for your represent from the next week onwards. There is
So
no week 12.
the videos on linear regression, will they be provided or like?
We will see. We cannot say anything for now. We'll see.
Okay. Can I ask one doubt from week 10 if, like?
Mom, can you continue with what you were saying?
Yeah. Like, okay. Yeah, so we was talking about the acceptance set. So all those subsets that like that will correspond to acceptance of your null hypothesis, those will consider as the those will come under the acceptance set. So if you
Okay.
go
Could
back,
you explain that? Could you explain that example you were saying? I mean, I have the
yeah,
same
I'm
question
going,
what the other person was asking.
yeah, I'm going back to the example. So yeah. Okay, so if you look at those examples, so we have taken some three possible sets. So in the first case, in the acceptance set, let's say if it is 5, if there are no such outcomes, then
No, no. The coin is tossed three times. No, the coin is tossed three times.
okay,
Are we just tossing it three times, or are we repeating that experiment more than once?
no, we are just tossing it 3 times. We are tossing it 3 times.
Okay.
Yeah. Okay, after tossing it 3 times, we are repeating it. So for each, you're tossing the coin 3 times. So you'll get you'll have set of 8 outcomes. Again, you will perform an experiment. You'll have some eight
Repeat the
outcomes.
experiment more than once. No.
Yeah. Then you will get different samples.
Okay, ma'am. So what I said earlier, was that correct?
Yeah, you were saying the same thing. Like somewhere the voice got
I got disconnected in between.
yeah. Yeah. So that is what we are doing there. And then yeah, then to identify what all sets if you have a acceptance set, what all then to decide whether you will accept your h naught and whether you will reject your h naught, all that you will have to check. So then we move to the type 1 error that we call as alpha, and type 2 error that we call as beta. Is there any problem
No,
in type?
ma'am. I'm
This
doubting
is
that.
clear. This is clear, right?
Yeah. What is A? Capital A.
Yeah, capital A is
Yeah.
acceptance set. Capital A
Okay.
is your acceptance set.
Okay. And what is that X? Sliced
What is
X.
that X
Transcripts,
only?
something else.
Where is that X? Wait. So I think this script X you have like all those 8 outcomes that you have, like when you toss the coin once, all like the script text will contain those 8 outcomes. That is our script text.
Is it
Ma'am,
possible to like visually
please.
explain this?
What is it possible to
Visually
Uh,
explain this?
yes, ma'am.
visually
It would be
explain?
helpful if you could use a whiteboard or something to explain these
Oh,
things.
okay, just give me a minute.
So let's make it a little bit more formal in general. So I will always talk of this acceptance set a little bit. We'll change it a little bit as we go along later. But for now, think of it as an acceptance set and the corresponding test that you have. So you have n IID samples according to some distribution, and you have 2 hypotheses about the distribution. H0 is one hypothesis, which we call the null hypothesis, which generally we normally expect to be. As we go along later, but for now, think of it as an acceptance.
Yeah, so again, so what part, like from the starting or just this
Yes,
one?
ma'am. It's better from the beginning, ma'am.
Okay. Okay, so let's say your null hypothesis is probability of it is 0.5, and the alternative hypothesis is probability of head equals 0.6. Now, when we toss the coin 3 times, we'll have some 8 outcomes. So let's write it here. Now, what we're saying is our acceptance set will be the set of all the outcomes for which
Could you start from the x1, x2, xn part?
x1, x2, yeah. So let's say you have some distribution x, and from that distribution you are taking some n samples. So you are taking some n samples from x, so x1, x2 up to xn that are coming from distribution x. And okay, I think it's better if we take this example.
Ma'am, let's say we have an experiment of tossing a
Yeah.
coin thrice and we are repeating this experiment 50
N
times.
times. Okay.
50 times, not 10 times, 50 times. Let's just take a definite value for n. That will be better for me to understand. So now can you proceed with x1 to x1, x2 and every other variable that's there?
Yeah. Can you give me 5 minutes? I will just like see this example properly, what is there in the lecture.
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
Yeah,
Okay, ma'am.
yeah, that
Yeah.
will be better because it's so long. I couldn't recall it properly what was there. Just give me 5 minutes, I will explain.
Okay, ma'am.
Yeah. Hello.
Yes, ma'am.
Yeah. Okay. So can we keep this topic on hold for now?
Actually, we are unable to proceed because
Yeah.
this is
Yeah.
the very first lecture.
No, no, no. You won't need all this once you move to the next lecture.
Okay.
Yeah, I had said in the previous week also, like I can so there will be revision session from next week. So for each week, I will revise the content from week 9 till 11. So there we can take this topic properly, this acceptance.
Will that be taught
part.
from the very beginning of the week?
Yeah, yes. Not. You mean first week?
No, ma'am. No, ma'am.
No,
In each week.
week 10, yeah.
Yeah.
For now, I will suggest you please move to the next lecture, and I'm not able to take it properly right now, so it will not be good. So maybe that session we can like explain it properly. This part, this acceptance set part. So don't stop after the first lecture. Like move forward.
Ma'am,
You
can you
want?
explain the p-value method then?
Yeah. Okay. Yeah. That's fine. So p-value is basically p-value is like the lowest significance level at which you like accept the hypothesis or at which like you reject the hypothesis. So that we call as the p-value of the test. So can we take the problem from there? P-value. I think it will be
Yes,
more.
ma'am. Actually, I didn't get the intuition of p-value. What is it?
Yeah. Yeah. So can you give me one example from some question?
Ma'am, there must be one activity after the p-value lecture.
Okay.
Activity
10
10.6.
point. Yeah, 10.6.
They have given a situation.
Yes. So by definition, what we say as p-value is the lowest significance level. So significance level, we know it is alpha. So the lowest significance level at which you will reject your null hypothesis. Okay. This is a formal definition of the p-value. Now,
Ma'am, I didn't understand how sir
uh,
draw that lines and how is it the lowest value at which we reject?
okay. So do you know about the critical reason?
Yes, ma'am.
So critical reason is the reason where your like you're rejecting your hypothesis, right?
Null hypothesis,
Null
yes.
hypothesis. You're rejecting that. Like yeah, that reason is a critical reason. Now, if your p value, so
I'm
there are
not able
few
to
tests.
see your screen.
Oh, okay, I'm not sharing. Wait. Can you say this?
Yes, ma'am.
Yeah. So, see, we know from the weak law of large number and all that probability that mod of x bar minus so mu naught less than some delta is so. Can draw here? No, I cannot draw here. Wait. Yeah. Now, this let's say this is your mu naught, and what we say is like the probability. This reason we call it as uh, 1 minus alpha, and this is our critical reason. These two reasons call it
So, ma'am, is
critical
1
reason.
minus alpha
That
the
is one is where you
acceptance region?
1 minus alpha is the acceptance reason. Yeah. So this reason, this one, this shaded reason is a critical reason where you like reject your hypothesis, and that reason is that we call it as that we denote by alpha. So what we want is your probability that we want is probability that mod of x bar minus mu naught is like less than some value. Let's say it is some c. So we want this probability to be at least 1 minus alpha. It means we want this thing to be like accepted, like you want at least this. Now the other way we can write it as probability that mod of x bar minus mu naught greater than equal to c, this should be less than equals to alpha. So this we call as this c we call it as critical value. So if this is our alpha reason, this is alpha, these two are alpha. So if this is our some t, this is our t critical, we can say t critical. um, Definitely. So, yeah, one thing we can do is whenever we like try to check whether whether you have to accept or reject the null hypothesis. One thing you can always do is you will find some critical value like uh, by solving alpha, right? You will find the critical value, and if the critical value if that critical value let me take example only. Uh, are you able to see the screen?
Yes, ma'am.
Okay. So,
Ma'am, can you take up 10.8 because before that only problems were discussed. Yeah.
okay, yeah. So, okay. Which problem you want?
Ma'am, any problem?
Okay,
Fourth maybe.
okay. So here the null hypothesis is given to be 65 and your alternative is mu greater than 65. So mu is 65 and alternative is mu greater than 65. Alpha is given to be 0.5. So you have to check at the 5% level of significance that okay, there you don't have to check. You have here you have to find the sample size needed if the power of your test is 0.95 and when the true mean is 67 kg. So what is alpha? Alpha is probability of accepting H naught, sorry, rejecting H naught
When
when
H naught is
H
true.
naught is true, right? So what is your test here? What is your test you will write here? You will write it to be X bar reject H naught if X bar is less than C or greater than C, right?
Ma'am, here we know that we have to use Z test, but if some different question is given is in exam, how do we figure out that we have to use Z
Yeah,
test or T
okay.
test
Why?
or
Yeah.
yeah.
Uh, so whenever it is given to you that the variance is known, so the have even if you haven't seen week 11 yet,
I have seen some only two
okay. So
lectures.
okay, so there is just one difference that you will come across. So in Z test, like how will you figure out is like if your variance is known, if the variance is known, then in that case you will have to use the Z test. In some problems, the variance will not be known to you. In that case, we use the student t-test. So that is the only way to figure out. So if you look at this question, it is given that your sigma is known. Sigma is 6, right? So here we have to use a z-test. So there are various tests. So for testing the mean, you have z-test and d-test. And for testing the variances, you have chi-square test. If you have two samples, you have f-test. And if you have, like, you also have two samples z-test. So in this case, we are using the z-test because the sample variances, like the variance is known to us. So that is why we are using the z-test, right? Now, alpha is yeah. Sorry, I'm not able to hear properly.
Yes, ma'am. Please continue.
Okay. So, in this case, your alpha is 0.05. So that is probability of rejecting H naught when H naught is 2. So your rejection reason is your test is you reject H naught if X bar is less than C. So your wait, I will true mean is given to be 67 kg and power is 0.95. So I've written down everything.
So, ma'am, basically T and Z test are for mean,
Yeah,
while
so if you have
chi-square and F test
test,
are for variance.
yeah, test for mean, you have set test and t-test. Only
Okay.
difference is when sigma is known,
Known, and here we assume sample
sigma
standard
unknown.
deviation.
Yes, yeah, sample standard deviation. So when sigma is unknown, we use a sample standard deviation. So that is the only difference. And for test for variance, we have test for variance. We have chi-square test and F test. Yeah. So F test we use for generally 2 samples, and chi-square is for a single sample. Now in this question, your H naught was mu equals 65 and HA to be mu greater than 65. Now your test is to reject H naught if X bar is greater than C, right? This is your critical value, C here. So alpha is given to be 0.05. And what is alpha? Alpha is probability of rejecting H naught when H naught is 2.
So X
reject
bar is greater
X
than
bar is
C.
greater than C given mu equals 65. This is your H naught.
Yes, ma'am.
This is 0.05. So you normalize it. So X bar minus 65 upon sigma upon root n. Sigma I think was given to be 6. What was n? Wait. So n was given to be, okay, you have to find n here. Okay. So sigma is 6 upon root
Ma'am, we
10.
have to
Right?
find the sample size.
Yeah, we have to find the sample size. That is why I'm writing here n.
Yeah.
Right? So
Yes,
X
ma'am.
bar minus 65 divided by 6 divided by root n. This is a normal 0, 1, right? Greater than C minus 65 upon 6 upon root n is 0.05. So you solve it, you get F1 minus F z of C minus 65 upon 6 upon root 10 equals 0.05. So from there you will get one equation. And the second thing that is given to you that power is 0.95, right? So power is nothing but 1 minus beta, and this is probability of rejecting H naught if your mu equals if HA is 2. So if mu is greater than 65. So what was the observed mean? Observed mean was 67 kgs. So in this case, we will take mu to be 67 kgs, right? This is what we have observed. Now, again, X bar greater than C. In this case, when you normalize, you take mu to be 67. So mu equals 67. So probability X bar minus 67 upon 6 upon root 10 greater than C. So again, if you solve it, you will get another equation. So you solve both those equations and you can get your C and N, right? Can you solve these two equations and find C and N?
Ma'am, they have given FZ inverse of only 0.05.
Fz inverse of 0.05. Yeah, because see, if you solve this, you will get what? The second equation.
Yeah.
If you solve it, you will get so you will get 1 minus Fz of C minus 67 upon 6 upon root n equals 0.95. So
Yeah, this quantity will be C minus 67 by 6 by root n
yeah,
will be FZ inverse of 0.05.
0.05, right? So in the option it is given just 0.05. So we know that Fz of minus A is 1 minus Fz of A. So Fz of 0.95 comes out to be 1.645 something, and Fz of, if we find 0.05, it comes out to be 1 minus it's not right thing to write. So it comes out to be 1 minus 1.645. So which one is given to you in the problem?
Ma'am, FZ of 0.05, FZ inverse.
Fz inverse of 0.0 yeah, so Fz inverse of 0.95, it's just going to be 1.645.
Okay, so ma'am, in this unit, there will be similar problems. Is it?
Uh, Similar problem as in like the way to solve the
In
problem.
every problem, we have to do similar thing.
Uh, yeah, every problem you have to do similar thing. You will some alpha will be given, somewhere power will be given, somewhere like you'll have to like use the same thing, just one-sided test, two-sided test, and all that. It's the same thing.
Ma'am, I have another question. Can I ask? It's from lecture 2,
Lecture 2, okay.
week 10, ma'am.
Week 10, okay.
Sir is solving a question. Could you explain that question? First question.
First question, wait. Uh, yeah, okay. Mhm. Wait, what is it? The first question,
Yes, ma'am.
okay. Problem 1. Consider 100 tosses of a coin. Okay, I'll share this screen. Can you tell me which?
Ma'am, actually, the entire question, is it possible? I don't understand the A, alpha,
Okay. Yeah,
1
okay.
minus beta. I don't understand.
Okay. Yeah, so the question says you have like consider 100 tosses of a coin, which could be either authentic with probability of it equal to 0.5 or counterfeit with probability of it 0.6. So your test is your T is a random variable is number of heads seen. So consider a test that rejects such not if T is greater than C for some constancy. What is the significance level of the test? So what is significance level? Significance level is alpha, right?
Yes, ma'am.
So what is alpha? Alpha is like given your H naught is true, what is the probability that you will reject your null hypothesis? It means what is the probability that you will reject the hypothesis? That probability of head equals 0.5. Like,
Okay.
okay, so that is called the significance level. Now, so this is alpha. Alpha is probability of head. That is probability of rejecting H naught given H naught is 2. So what is H naught? H naught is probability of head equals 0.5. So that is what we have to know. Probability of head equals 1 by 2. Now T is given to be number of heads seen. So for each tosses of a coin, so you have a coin, you are tossing it either head tail. So you have 100 such tosses. So T will be your binomial random variable, correct?
Yes, ma'am.
So T is binomial 100, comma probability of head, right? So
Yes.
if you like write probability of so A is your acceptance set that we call. So probability of A complement given probability of head equals 1 by 2. So what is the probability of A complement? So now this A complement here is like T greater than C. So so probability of T greater than C. So what is the mean of T?
100 into a probability of heads.
100 into 0.5, so it will come out to 50. So yeah, And then you need the
But why
standard
do we
deviation.
need the mean? Why do we need the mean?
So if you want to find the alpha here,
Okay.
yeah.
Alpha. Okay.
So like you try to convert it into that normal 0 1 form, the random variable. So you will have to subtract by the mean of the t and divide it by the standard deviation of t to make it in the form of normal 0 1.
Could you solve it in a board? Is it possible?
Yeah. Okay.
Yes, ma'am. Please. Thank you, ma'am.
Yeah. So what was given to us is probability of fed to be 0.5, probability of fed to be 0.6. This is your H naught, this is your HA. Now you have to find the alpha. You have to find the alpha. So alpha is probability of rejecting H naught given H naught is true. So H naught is true means probability of fed equals 0.5. And your test was t greater than c, you reject H naught. So you have to find probability t greater than c given probability of fed equals 0.5. Now what is t? T models the binomial random variable with the number of heads equal a total number of outcomes at like total number of trials 100 and probability is probability of head. So in this case, we'll have to assume probability of head to be 0.5. So t is binomial 100 comma ph. So t minus what is the mean of t? 100 times n times p. So 0.5.
Ma'am, can you please repeat the previous step?
This step.
Yes, ma'am.
So it was mentioned in the question. I guess this rejection reason,
Yes. Okay.
right? You will reject your H naught if t is greater than c. This was mentioned, right? So,
Okay.
so rejecting H naught given H naught is true. So H naught is true is value of at 0.5, and this is a rejection reason. So T greater than C.
Okay.
Okay. Now, what is the mean of T? T models binomial 100 comma pH. So mean is
But
n times T.
why do we need the mean?
To find alpha. If you want to find alpha, we need the mean.
Okay.
Like you
Okay,
can
ma'am. Go ahead.
so if you do it, you'll get mean to be what 50, right?
Yeah. Okay.
And so t minus 50. What is the standard deviation? So n times under root of n times p times q. Sorry, 0.5. So 0.25 into 125. So it is 5. So
Okay.
same thing, you will subtract and divide by 50, subtract by 50 and divide by 5. So 5 is the standard deviation of t and 50 is the mean of t. So this is nothing but normal 0 1 using CLT.
Okay. Okay, ma'am.
So this is going to be 1 minus fz. So this we can write it as z. So this in total, it's going to be 1 minus fz of c minus 50 by 5. So this is going to be alpha.
Okay.
What is the next thing? Wait, just let me check what is there. Yeah, so the next thing is finding the power. So power is what? Power is 1 minus beta. So power is 1 minus beta, and a power will say is like given your alternative hypothesis is true, you are rejecting your H naught.
Um, um, Given your, can you repeat that again?
So power, what is power? Power is 1 minus beta.
Okay.
And what is beta? Beta is accepting your null hypothesis when the alternative was true.
Okay.
Accepting the null hypothesis when alternative was true. So
Okay.
1 minus beta is you are rejecting the null hypothesis even when the alternative was true.
Is it same as rejecting the alternative hypothesis when alternative hypothesis is true?
Rejecting the null hypothesis.
Rejecting the null hypothesis isn't as same as accepting the alternate hypothesis.
Uh yeah.
Okay, so beta is accepting the no. So
Beta is wait. Beta is probability of accepting your null hypothesis. Sorry, accepting your null hypothesis when alternative is true.
so rejecting the alternate hypothesis when alternate hypothesis is true.
Is the power, that is 1 minus beta. So the power was given to us, I think it was 0.95. Okay, that we have to find. So power we have to find. So again, rejecting H naught. So probability T greater than C, right? So given probability of H equals 0.6. Now given probability of H equals 0.6, what is the mean of T?
Mean of T is 50.
Not 50. That in that case, probability of head was 0.5. So it was 50.
Okay, here it has
Now you
changed.
have probability of head to be 0.6 to 60.
Okay, 100 into 0.6, 61.
60, right? So
Yeah.
in this case, you will just do T minus 60 divided by, again the standard deviation will change. So it will come out to be 100 times 0.6 into 0.4. So and 24 under
24.
root of 24. So there you will have under root of 24 and you will get 1 minus subset of C minus 60 by under root of 24. That is going to be your beta. So this is not what is done there, like what I just explained. There it is like see rejection is about T greater than C. So T greater than
Okay.
C as in she should be like whatever K, T is the binomial distribution. So T was the binomial distribution, which is 100 with the parameter 100 and probability of head. And your alpha was probability of T greater than C given probability of head is 0.5. Now T is binomial. So you have to take like T will like take the value from 0, 1, 2, and so on, right? So T is the binomial random variable. So this we can write it as NCK. So N is 100, CK, P to the power K. So P will take it as 0.5, P to the power K, 1 minus P to the power N minus K. And your K should vary from like C plus 1 because T should be greater than C. So K should vary from C plus 1 to 100.
Mama, the given conditional probability equation, won't we write that as probability of T greater than C intersection with probability of H is equal to 0.5 upon 0, probability of H is equal to 0.5?
Yeah, that is fine. So okay, so what, given this is true, like if you already know that this probability of H is 0.5, You can just
Okay.
substitute it there. No? So
Yes, ma'am, but
the
the denominator is missing, no?
the denominator is missing.
We have to divide the entire equation upon probability of
But
x is equal to. You get what I'm saying, no?
yeah, I get what you're saying.
Yeah, I'm asking why are we not using the conditional probability formula here? I understood what you have written in the below part also. I just have why we are not dividing by the probability of h is equal to 0.5.
Okay. So if we do that, mm,
Ma'am, is there any relation between significance and
hmm,
confidence level?
significance and confidence level. Yeah, so yeah, so in the confidence level, like this this is a 1 minus alpha, right? And this is a alpha. So this alpha is same as this alpha, actually. They both are same. Um, there you're not dividing it by 0.5. Mm.
So, ma'am, basically confidence interval is 1 minus alpha.
Confidence interval is 1 minus alpha, yeah.
Okay. Ma'am, here what
Uh,
I think is given that
uh,
heads gives
uh,
the probability of 0.5, it
hmm.
follows the binomial distribution. That's why maybe
Yeah, that is no, even if it is probability of it is 0.6, it again follows the binomial distribution because T is binomial 100 comma pH. Um,
but it follows binomial with the parameter 0.5.
yeah, it
That
follows
will be the
binomial with the
intersection, but yeah.
uh, yeah, that is going to come in the intersection. So, but why not we are dividing by probability of, yeah. Okay, we'll check. Can you post this question on Discourse?
Yes, ma'am. Okay.
Yeah.
Ma'am, can you continue what you are saying?
Uh, this one.
No, ma'am. The next slide, you are explaining something. Before I ask the question, you are saying something.
This part.
Yes, ma'am.
Yeah. So this random variable t follows the binomial 100 comma pH distribution, and your alpha was rejecting H naught when pH is at zero point 0.5. So probability t greater than C is what. So this was a rejection reason that is given to you in the problem. So t greater than C. Now, uh, C t is a binomial random variable and n is 100. So t can take the values from 0, 1 to up till 100, up to 100. And we want t to take the value greater than C. So, and we know that t follows a binomial distribution, and it is not. So if you write the distribution, it is what? It is nck p to the power k and q to the power n minus k. So k should sum from where? It should start from C plus 1 to 100.
Okay, ma'am.
That was the only thing I was saying. Same thing in while calculating the power. There also your k will vary from C plus 1 to 100.
What is power, ma'am?
Power is like yeah, power is like, even though you know that your alternative is true, you are rejecting your null hypothesis.
Okay.
So like this alpha and beta, we call it as type 1 error and type 2 error, right? Type
Yes.
1 error and type 2 error. So why we are calling it as a type 1 error? Because see, even though we know that your uh, null was true, your null was true, still we are rejecting our null. So by rejecting our null, we are making an error. So we call it an type 1 error, and that is our significance level.
Okay. So
And
alpha is significance level and beta is power.
no, beta is not power. 1 minus beta is power.
Okay. Okay, ma'am.
1 minus beta is power. Beta is probability of type. Beta is type 2 error.
Okay, ma'am.
Ma'am, lowest significance level is the
P value.
p value. So how do we do problems based on p value, ma'am? Sir has not explained an example.
Okay. So it was in lecture 10.6.
And ma'am, will it be given that you have to do using p value or by general method?
No, not generally. You can use anything. Can I show the screen? Okay, so if you look at the first question, um, it says you have a coin and you would like to check whether it is biased or not, fair or not. Let P be the probability of heads. And let the null alternative is this P equal 0.5 and P greater than 0.5 is the alternative. You toss the coin 100 times and you observe 55 heads. So it says, can you reject H naught at a significance level of 0.05? So yeah, so what is alpha? So the first question is, again, you will have to find the critical value and check. The first problem, are we using p-value? So alpha is 0.05, and that is probability of rejecting H naught. So p hat greater than say given p equals 0.5. No. Which screen you are seeing? The portal, right?
What, ma'am?
You are seeing the portal, right?
Yes, ma'am.
Yeah, okay. I'll just write it somewhere and then I can share the other screen. Equals 0.5, 0.5. So the first question was when alpha is 0.05, uh, do we accept or reject the null hypothesis? So alpha is what? Probability of rejecting H naught given H naught is true. So probability of T greater than C given P equals 0.5 is 0.05. So T, we can say it is just some P hat in place of T, we can say, and the P is 0.5 here. So 0.5 divided by what is the variance? It is n times minus P.
Ma'am, sample size and variance are not given.
Sample size and variance is not given. No, sample size, okay, number of trials was 100. So variance is going to be PQ by N. Let's go. Yeah. Yeah, so variance, variance in this case will come out to be N times PQ, sorry, PQ by N. Okay, so P is 0.5 and Q is 0.5, so 5 by 100. And do that, it will 0.05 plus 0.5 comes to 9.564 plus 0.5 C is 0.55. Can you just check this calculation? So this is coming out to 0.582. So using the alpha value, we will get except H naught.
Hello, Nikita.